Hello and welcome. I'm Bill Wake. We're here practicing evolutionary design this week by swapping an old style recursive descent parser to a modern style parser combinator approach in a basic interpreter we wrote a couple months back at this point. And we'll focus on expressions today, but unfortunately we have a little more work to do on our adapters. So let's start with that. Okay, so we left off, and we were getting an error on this test, right parent error in dim, and the error is it's supposed to have a right parenthesis here, and we hope to get this message, but what we're getting back is position 8, column 8 coming back as the token index. And as promised, I took a quick look at it. Well, I thought it'd take longer than it did. But about 5 minutes after we finished our session, I realized what was going on. The tokens here, they're keeping track of the columns. And so that in a future version, we'd like to put a little arrow underneath the code and, point at this column and say, hey, it was missing right here. But the value we're passing back from our new style parser is the index of the error in terms of tokens. And the column is different than the index. So the index, this is 0, 1, 2, 3. Well, 3 is the parenthesis, 4, and 5 or something like that. That should be the index. But instead we got the column from the token. And that's a pure error in our wrapper. Okay, so let me continue from here. Okay. I don't know if we're out all the way yet. I guess we're stuck here. Oh yeah, it's a out of bounds thing, because failure index is 8. Oh, did I have it a second there? There it is, 8. And analyzer.tokens, I don't know if I can look at them. Oh, they're only, 7, 0 through 6. Okay, so the index is off there. All right, and the problem is, let's see, we're in, what is this? This is rep new. I think the issue is really wrap old. Okay. We throw an exception, a token error, and then we get this old index. Where's that coming from? Oh, it's the starting point here. Oh, sorry. Yeah, token.column. That's what we're getting. So this part's right. It's saying if you fail, go, adjust the index backwards to the position you started at. But the problem we have is if we're reporting the column of the failure rather than the token index of the failure. And I think, we've got a failing test, so we can do this in good conscience. I want to say the failure index, maybe it's even the failure token index, is really it's the token that we have that's interesting. So it's really like tokens dot first. Yeah, that's the one. First index of token, and then we know it's coming from the list. We know it's coming from the tokens array. Analyzer.tokens. We know it's coming from the tokens array. That token had to come from this array, so we know that it will have an index. Now, what's my problem? Oh, I'm not using it. Okay, and let's return failure token index instead. Okay, I'll just run all tests. Yeah, okay. Okay. So what we've done with this, let's find dim. So we have our dim statement. It it works by calling, so you see the word dim and you see a variable, and um, you call dim info. Dim info captures a variable and a left parentheses and its dimensions. Okay. And this repeats with the comma separated. So you can have multiple declarations of dims, declare multiple arrays on a line. Okay. And then, all right. So, so I'm seeing a potential bug here. um, we're not enforcing anything on the types of these expressions. So if I said dim a parenthesis b dollar, a string for a dimension, doesn't make any sense basic wise, but it's allowed. Okay, so let's add that on a to do. Pull adapters to a separate file. That's good advice. Let's see. So this is dim should enforce numeric types in for sizes. Okay, makes sense to allocate a 3-dimension or an array with max index 3, but it doesn't make sense to allocate one with max index. This is a string. Okay. Re-enable test right parent error in dim. Well, I think we were running at, let's see, test right parent. Okay, yeah, it's re-enabled. Good. To-dos. So let's see, today's the 10th. Recursive set parsers return. Okay, let's turn that into make wrap hold use the index of the token, not its column, for error report. Okay. Make sure everything's still running. I don't think I changed anything, but you know. All right, and so this is fix error in wrap old, where it returned token column instead of token index. Now I think it's a little I don't know. These things often don't really make much difference in performance, but it is a little bit of a performance oddity. Like, I'm scanning backwards, looking around for this old, I'm scanning through my whole list of tokens, looking for this token I already know. I could change my throw to not throw tokens, but throw token indexes instead. But really think about the situation here. This only happens when there's a syntax error, which is already not most lines. And it only happens once because we really only report the first error in the line. And, it just isn't a high frequency case. If you had 100 tokens in a line, that'd be a huge line by basic standards. Usually they're probably 20. So it's just not a big enough performance hit to worry about in the grand scheme of things. And the other side of it is, this is the wrapper, and it's going away as soon as we get rid of the old parsers. So even if it were a small performance hit while we're wrapping, I'd take that hit. It's just not that big a deal. But knowing it's going away makes it easier to tolerate. Okay, let's see. Pull adapters to separate files. Yeah, because I think Yeah, it kept bouncing around yesterday between the old and new, the adapters and the basic, um, the rest of this class. So let's just pull them out, and we'll create a new file. Hey, it's going to work again. Parser adapters. Okay. And I probably need to import pcombo. Okay. Make sure that works. Really wish I could default this flag on, but there you go. Okay, what's next? Pull adapters to separate files. The dim should enforce. I'm not gonna do that now. It's true. It should. New parser for dim calling old parser for dim info and error handling. Okay, we did that. Okay. Make Lexer provide line of yielding an array of tokens. Yeah, this is let's see. Let's look at that one. I think that is probably our next thing. And then I want to start in on expressions, which is a big topic. Okay. Let's see. So syntax analyzer. In here, we added this stuff. We sort of changed the way it works. It used to take tokens one at a time from the Lexer, and now we're loading up this array of tokens. For compatibility, we're doing it in a way that's compatible, so the old parser can still work this way, but the new parser wants to be able to kind of refer to the whole thing. And again, it's not that big a list. Maybe 100 items at most ever, probably. So this code, it's calling Lexer, and it's appending stuff into this array. All this stuff, I mean, this can probably happen at the bottom. This whole bit is really just getting the array of tokens from Lexer. So my idea is, why not just have, instead of calling Lexer.next, let's call Lexer.line, I think I said. Okay. And it's returning a whole line's worth of tokens. Okay. So we're going to do a move method, basically. So hopefully this can refactor. Yep. I don't know if I can call it line. I might have used that name already. Didn't? No, I did. Oh, it should have blocked me from the... Okay. Let's call it... well, let's leave it how it is for now. That's okay. Our goal is to move it over to the Lexer, so, that's okay. All right, so... The deal is I have to think about parameters and stuff like that. Do I need access to the parser to do this? No, I'm just going to return tokens. So let's make this thing return array of tokens. Okay, and we'll assign it here. Tokens equals extracted function. So our tokens is this array here, and we'll do that. And we need to return those tokens. Okay. So this now, it sets the tokens, it sets the index, calls next token. Yeah, we can improve that too, I think. Next token just adds that. Okay, we could not call next token and just leave it 0. That's probably even better. Okay, so let's see if this works. Okay. So this function, it only talks to the lexer, is the only object it talks to, and it certainly doesn't talk to the syntax analyzer. It just returns a result. Before, let's do this. Let's var tokens equals that. Var tokens of type token. Okay, so I was touching the class variable. Now I'm only touching a local variable. All right, and this is local, and that's local. Append is operation on here. Okay, now my statement is more true. I hope it's true, but we're only talking to lexer and the array stuff, which is lower level. We're not talking to the parser stuff anymore. Okay, so let's push. This is refactor extract method to get line of tokens, and we also adjust start index directly to 0. Okay, now this function being a pure function of the lexer and the tokens, let's move it over to the lexer. Okay, init. Well, there's next. I guess that's probably okay. Let's find line. Okay. Okay, so that name is not in use, so we don't want to file private. Moving it in here, we're going to call it line, and it's really just next. We don't need to mention lexer because that's self. Okay, next. All right, and let's see, anything else we need to do? I don't think so. No adjustments. Okay, and now syntax analyzer can call lexer dot line, and let's make sure it works, but we shouldn't need this function here anymore. Okay. All right, so we create a lexer, dig out the tokens, set the index, and go. All right. Now, let's see. I don't know if it's a big deal, but our adapter tests can make use of that. Okay, so we were doing this stuff before, but that is really lexer.line. Lexer.line. Okay, so that gives me an array of tokens. I don't need to reference wheel. Okay, I got tokens there, and then this is token sub 1. Okay, that's the plus. Okay, so let's make sure this works. Token line. And token 2 is token sub 1. And reference here. Okay, make sure this one's good. Tokens. This is tokens. Token 3 is token sub 2. 0, 1, 2. Okay. Run the test. Oops. What do we got here? Well, let's just undo. Okay, so I said tokens equals this dot line. 1, 2, 3. This is tokens. One, two, three. Tokens. Did I say token sub 2? Oh, token 3 is token sub 2. Okay, line 0, column 2. Column 2. 0, 1, 2, comma. Oh, end of line. Yeah, I definitely have that stuff there. Oh, yeah. Okay. It's really token sub 2 dot dot dot. We are changing what we pass back. So the line actually inserts a new line and an end of input marker. So this is a bigger array coming back than that was. Okay, so I think that should be better. Yeah. Okay, I have to be watching for that. This dot line is tokens. Token 1 is tokens at 0. guess the rest is old. Okay, let's provide that. Expressions. Okay, let's go back here. Now, in the setup for the week, I mentioned one of my ideas was, oh, it'd be nice if expressions wasn't so complicated. So this is why I say that. We have each one of these corresponds to a grammar rule, which corresponds to a method, since it's recursive descent. So we have expression, calls, or expression, calls and expression, calls negation, calls all the way down till we get to factor. And factor calls parenthesized expression, which calls expression. So this is a recursive, it's a recursive setup. Okay, so if you look at the other possibilities for a factor, it could be a numeric factor, fine. It could be a variable, but variable also covers the case of an array access, in which case its dimensions can be expressions. Okay, so variable references expressions. Predefined function has arguments, which are expressions, and user-defined function call has arguments, which are expressions. Excuse me. So all those, I don't know, what is that? 3, 6, 9, 10 levels and 14 methods. Okay, all those together, they're everything that goes into expressions. Now, the idea I had was it'd be nice to use, we did Dijkstra's shunt yard algorithm, which is kind of a basic way to do an operator, something that's based around the operator. The operators know their precedence and their associativity, and the algorithm takes that into account. So if you were doing that, then you wouldn't need 10 levels. You'd have 1 or 2. Okay, so that's one dimension of this. So when we set up our adapters, at the very beginning, I talked about we need to be able to wrap we need to call the old from the new and the new from the old. And this sort of recursion or mutual recursion is why, because imagine if I could only call new methods, I'd want to start at the bottom and put a new method in. So a numeric factor looks like my only possibility there. I do that to the new style, and then factor could call that, and that's great. But then when I go up a level and I try and do factor, I have to call parenthesized expression. And if I write that in my new parser and I can't call old things, then I'm stuck. Okay. So we value both adapters so we can call the old from the new and the new from the old, and we don't have to worry about these loops. Now, there may be a way around it, but it's painful, to get rid of that mutual recursion. You'd end up rewriting the whole thing in the new style and not being able to use it until the very end or something. It's just not incremental or evolutionary. So that's why we like both levels of adapters. There are situations where you don't need it, but mutually recursive types is not one of them. All right, then the other thing I did was I did some analysis to say which methods, what kind of type checking is going on basically. And so or expressions and expressions, they require floating types, numerics. Okay, you can't say $A and B, or quote this and quote that. It doesn't make sense from the operator's point of view. So those Boolean ones, they all require floats if they're using the operator. Okay, the relational one just requires matching types. So you can say $A equal to B, or $A less than B. That's a reasonable comparison. And so it can be either two strings or two numbers, but not a mix. Okay, we're not JavaScript. And then the last couple, some things specifically require numeric. Okay, so I mentioned variables. The indexes on arrays should be numeric, and I don't think we enforce that. So that's where I saw that bug coming in. User-defined function calls, that far right one, it doesn't let you, basic doesn't let you define string functions on your user-defined functions. So the argument should be numeric. And again, I'm not sure if that enforces that or not, but it should. And then the predefined function calls, it does have a variety of parameter types. Some take strings, some take integers, some are optional. There's just a bunch of stuff to check. Okay. And so why these checks show up, like when we do our translation to our new style parser, there's something like a pipe sort of operator that lets you call a check function basically. And we also need to call the construction functions. So each of these types, expression methods, expression, or term, power, factor, all those, every one of them produces an expression, the tree type of capital E expression. And again, we have that pipe operator that lets us build things from things that got parsed. Okay. So I don't know where is the best place to start. There is no bottom because it's so recursive, mutually recursive. Factor, I don't know. Maybe the operators would be more fun. Like start a little easy. So what if we did power? I know that one's actually kind of messy. Let's do term. And really, because we can wrap anything anywhere, we could pick anything and it would work. I just want to make things kind of go easier for us. One of the things that happens is or and plus, minus, powers, factors, they all let you repeat multiple times. Relational only lets you do once. So you can say A less than B, but not A less than B less than C. And let's see, negation is unary and power has unary minus in it. That's why I think it's harder. So let's do term, because I think term, sub-expression, and expression or expression are all very, very similar. And let's start with term. Okay. Now there should be a method for it. Term. Okay. Okay, so term is a power, and then times or divide. We save the op. And we call power again. So, okay, so this is kind of one of our separated by things. You have powers separated by times or divide, and then we've got to do the type checking somewhere, and we have to build. Okay, now when I see the building here, I don't know. I have a twinge that says like, ooh, I've got the op type, but I don't have the op. I don't have the whole token. So we got to make sure our type checking needs access to the tokens, but our builder does not. Okay, so let's figure out term. Okay, so let's we're going to build the parser one level up just to keep things moving, I guess. Okay. So I want to use the word term, but let's say term expression. We can rename these after we get rid of the old term method. Okay. So a term is a power. Okay, so we got to wrap that because it's an old style call. wrap old self power. That's the power operator. And then it's a separated by. We need to keep the operators because we need to store it in the eventual construction. Okay, so this is power and then this is match times or match divide. Okay. So this whole thing, this is basically the skeleton of the thing. So the method looks exactly the same as this one. That's the other thing annoying about these, right? It's like call something, check some tokens, call it again, check the interface and build the operators, but trying to genericize that, it's just too painful. All right, but that's kind of what we've done with this. We've gotten down to the essence. That's power times and divide. Okay, so this core, it doesn't deal with keeping track of this. It doesn't keep track of this, and it doesn't keep track of this, but it does deal with all the rest that does the matching. Okay, so, all right. Now, do I want to? I need to require float types. Let's see what that looks like. Left and right. Okay, yeah. The problem is the let's see, was it bracket? Nope. No, I don't know how to get back there. Navigate. Control. There we go. Okay. Yeah, this thing, let's see, this guy, it produces the whole well, I don't know if you'll even if you were here and paying attention, you might not remember. It's going to return us whatever power returns, which is an expression, and then it makes a tuple of that and the result of this stuff. Well, this stuff is a array of tuples. The first item of the tuple is the operator. The second item is the power again. Okay, so I have a require float types, but it's kind of it's got different stuff coming in. Okay, and I'm always stuck. I mean, I've got the. It's interesting when we're doing these replacement kind of things, because my tests they come in at the level of the language, and they don't try to test every combination of require float types. Now, let me see. I can see who uses it. There may be a direct test. No, there's not. So all these are tested through the language level tests in parser tests. Okay, so let's see if we see the word require. Numeric type is required. Okay. Yeah, so type mismatches, type numeric type required. All these things are done in the language level. I call check error that does that. Okay, so if I write my own require float types that takes this mess in, all right, let's see what the type is. Oh yeah, it's your good old, separated by whatever's. Okay. So I need a require float types. Now he might, let's call it func require float types. Okay. And what's coming in? Well, it's a tuple. It's a tuple of an expression because that's what power gives us. Let's demonstrate that. Here's power. It returns an expression. Okay. And then it's an array of tuples. And the array is, well, match times is a token. And the power, remember this calls this one back and forth, is expression, as we know. Okay. Da, 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 da. Okay. And the whole thing, well, this one throws an exception. All right. Let's get that. Let me go to my examples down here. So this is check is what we're going to do, because check, it applies a function to the results of a parse. And if you succeed, then it just returns the parse. If you fail, it returns an error. Okay, so sum should be even. What do we got? Int string question mark. Oh, okay. This is our error return. Okay, so let's see. We don't really use that, do we? Values that count. Sum was odd. Yeah, let's returns failure when check fails. Okay, so sum should be even. I may have to look in here. He's not returning success or failure. I think, yeah, he's returning nil if it's satisfied, and basically the error positioning if it's not. Okay. Let's see here. So this returns int string optional. Something's a little. I almost should be naming that type, I think, but that's the way it goes. Okay. So require float types is going to look a lot like require float types down here. If I can find it. Should have clicked. Okay. If left is not number or right is not number. Okay, if either one's not numeric. Hey, Astrid, nice to see you. If either one's not numeric, then we've got a problem. So I'll just borrow this just as a reminder. We're not going to do that exact code. Okay. So let's find our term. Term expr. Okay. So the old code is something like this. Okay. We have a different setup. Okay. So if you have, this is the first expression. If that's a string, it's not a problem because it's only when you involve an operator. So if if the array, let's see, I don't know if I can name this. First expr and pairs. Okay. If pairs dot is empty. Okay, am I not allowed to do this? Okay, so if there are no operators, then there's not a problem. Okay. Spec parameter followed by a colon. I have to peel it apart, I think. So the bad side of this is these arguments are just not very sensible, are they? Let this equals argument. Okay. I thought I could do it in the parameter list, but I guess not. Okay. All right. So our float type, if the first, we want the first argument and the second argument. Okay. So if it's empty, it's a nil. Okay. If it's not empty, then the first expression has to be numeric. If it's not a number, then we have an error. Okay, so we're going to return. What are we returning here? Okay, I'm not happy. Do I have enough information? I don't know where the token is to report the error to, I guess. And that goes back to this type here. It's almost like my type needs some indexes. Well, the other way to do this okay. All right. So the structure is the same as this. It's not the same plugins, but the problem I have here is I don't know the names. I don't know where to report the error. Okay, sorry. Let me back up a little. We're going to try and replace term. Is currently it's a recursive descent method, so it corresponds to a grammar rule. Term goes to power, and then repeat plus or minus or times or divide power. So power times power times power times power. And once you do that, you need to verify that everybody's got the right types, and you need to verify that you need to build the actual expression that comes out of it. Okay. And so what I've done so far is I've said, okay, this is that grammar rule wrapped in the new style. So it says my power routine is an old style method, so I have to wrap it, but I call power, and then it's separated by one of these two operators. And the result of this has this type. It's an expression that corresponds to this one, and then it's an array of the tokens and the repeated expressions. So it's power times power times power goes to the first power, and then an array of times power times power. Okay. The challenge I'm having is there is an operator. I think it looks like this, something like that. It's a check operator, and the idea is you pass it a function of just the right argument type. Okay, and it's going to apply this function to this expression, comma expression cluster, I guess you'd say. Okay, and what it's supposed to do, or the idea was, it would report any errors. So in this case, I want to report something. I don't know what index to use, but the message is type mismatch. Okay. Yeah, it actually a better message. Well, a better message might be numeric type required, because that's really what it's requiring here. But it gets that message back, and then there's more that has to happen, and then what's that? And then in the end, if nothing else is wrong, it returns a nil saying everything's okay. Yeah. But I can do the analysis. That part's fine. But the problem is when I find a problem, oh no, maybe I'm okay. Yeah, maybe I'm okay. The token, oh no. And back to knowing the token versus the column of the error versus the index of the token. Okay. Yeah, so I don't know I don't know the location of this token in terms that I can return this value. The tests are all at the language level. So if well, let's find one that says type mismatch. Okay. This isn't exactly the case we're looking at, but it's the kind of test you'll have. So square root requires a numeric argument, and it doesn't have one, so require float types says type mismatch. Okay, so the errors are all, the tests tend to be at the language level. I give you a construct, you either give me back a tree of successful expression or statement tree, or you give me an error message. Okay. So in that sense, I can just kind of replace algorithm if I can do it in a straightforward way. But unfortunately, I don't think I have the information. Well, I sort of do, but it's not ideal. Okay, so we had this issue before. First thing this morning, we had a bug in the wrap old, because in the error case, it was returning the column. It was going to the token and saying, "Hey, what column was the error at?" But this integer index is really it's not the column. It's the position in the tokens array. I can get around it, but I don't like it. So I don't mind a replace algorithm if it's going to be covered by all the existing stuff. I'm not too concerned. But the more complicated this gets, the less I like to believe it's going to be okay. Now, there are differences in philosophy on these two parsers for sure. So it may be that I can't get by with the same cases, but I think I can, because I've got expressions where there's just a single entry, so there's no operators, and this thing should be fine. And if there are operators that need to be numeric, the first one not numeric, if I've covered the symmetric cases left and right, then I'm okay. Well, I think the thing is we have a language level test for this already. So let's see. I may have missed your question at the wrong moment. Where'd the parser tests? Let's find these others. That's all the function ones. Okay, strings can't do arithmetic. Okay. Yeah, so here's one. The left is correct. Yeah, we've got both sides covered. If the left is numeric and the right, the left is a string, the right is numeric, or the left is numeric and the right is a string. So this case definitely will test what we're talking about, and it tests both versions. So okay, I guess token is a real token. So I mean, I can find that index, and this is an error case, so it's not completely horrible, but I hate to go outside the method. All right, but let me push it through and see. Okay. Okay, we have an operator. Okay, so we know pairs is not empty, so let token expression equal pairs sub 0. Okay, we know that's legit because we have some. Okay, and then, oh, it's already non-optional? Okay. Okay, so given this token, if this fails, it's really failing at the token. Well, for now, let's do this. Token position equals tokens dot first index of token. Okay, so I'm going to say this is definitely legitimate. This is legal because token is guaranteed to come from tokens. That's the only way they get into this class, basically, and we can find it. All right, now this index is the right one for the message. Okay, so it's a little clunky. Okay, now we need to run through the loop of all these. I mean, I know we're covering them all, but okay, let's take pairs. Let's see. I guess we're gonna run through each. Okay, and we're looking for anything problematic. So, this is a token and an expression in this. All right, and if expression dot type is not number. We're going to return well, let's get through this and then we'll deal with the sins. Tokens.firstIndex and a message. I have an extra. Okay. Running through each one of these, looking for that. Non-void return value in void function. Oh, it went away. Okay, good. No, it was the compiler gets behind. No. Yeah, it may be something like that. Yeah, there's pairs dot is it like first. Where? We don't care about the index. Okay. I don't know. All right, we got an index. If failure index is nil, then there's no problem. Otherwise, we have a place where there is a problem. We need to return of that's the token. We know it exists because it just gave it to us. And I don't know. I'm not liking this. Yeah, the contrast is striking to me, and it's because the in the original one, we're checking the pairs as they're created. In this one, we have to check them all at the end. And let's see, failure index is not nil, so that has to be that. Okay, the expression. Okay, we don't need that if that failed. Okay. Wow. Yeah. I may want to go back and test that more. Okay. At any rate. Okay, let's look at it and see if I believe it. we pull out the first expression in the pairs. If there are no pairs, then there's no problem because it's a single thing with no operators, so there's no type checking to do. Return nil, we're done. Otherwise, we're going to pull out the token, which is the operator, and we're going to say at the point of the operator, we detected that there's a type mismatch, and we'll return that. Then we're going to run through the pairs and check for non-numeric types. If there are any in the pairs, then we're going to, if there aren't any, we just return nil. There's no problem. If there are any, we're going to look up that index and then return that. Okay. This can't fail because we're not calling it yet. I shouldn't say can't because it's messed up enough. All right. Now I think I'm ready to substitute. All right. So we have a new style parser that is intended to capture everything. Well, it's in this method. It's capturing everything up to here. We don't have anything that builds the left and the rights. Okay, so again, this simple line is going to get complicated. Okay, I don't think it's horribly complicated, but it's a little complicated. Okay, so this is func make binary expression. Okay, and it's going to get some stuff and it's going to return an expression. Okay, so it's supposed to do the work somewhere. There's got to be a call that looks like this. All right, now the argument coming in is the same as here. Okay, it's an expression, list of tokens and expressions. All right, and we're going to start the same way, getting this first expression. Okay. If there's only one expression, then we just return it. Okay. Otherwise, and that corresponds to this. Initially left as term, and we return it. Otherwise, we accumulate. Okay. Now this, we've got an expression and a list. Okay, so I always get the syntax wrong, but let's do pairs dot reduce. Okay, initial result and partial result. The initial thing is the first expression. And then the rest, okay, I'm going to type it again because I can't keep that in my head. Partial result is a result and a token and an expression and it returns a result. Okay, so it's left is that a reserved word? Left token right in that. Okay, so pairs.reduce result token and expression. So it's peeling off one at a time from our things and accumulating them. Okay, so this should be kind of like our op2. Okay, op2 the operator is token dot type. The left and the right. Okay, parameter does not support destructuring. Fix, sure. Yeah, okay. I think maybe I can't do this one. Left and op expr. Let op expr return that. Okay. Okay. I don't think it's... maybe I'm forcing myself to do these things, but reduce is really the right operation for this. We're taking our left-hand side. Our first expression is the left-hand side, and it's going to take whatever you have so far. It's going to start with that, pass that in as left, and then pull out the token in an expression as op expression. And then we're going to say, well, given what you have so far, you should do the operator, the left so far, and the right. Okay, and maybe this is left so far would be a better name. Okay. Get that thing quiet. Okay. This feels more right to me. This felt very clunky. This feels like kind of what you got to do. It's now, I don't know if, okay, we'll see if this works, and then I may be able to get rid of this in the end. I think it might work okay with an empty list. I think it will, actually. Okay. Good. Now this pipes to our make binary. Okay, so let's see if I can format this a little nicer. Okay, kind of crazy, but it's such a nicer expression if it all works. Okay, so I have let's call it term parser maybe. Like I said, I'll probably call it term in the end, but that's okay. Okay, so power separated by times or divides, require float types and everything, and make a binary expression. All right, I think that is correct. Okay, and now I want to call term parser dot parse let's get this right. I think I need to do a wrap new of term parser dot parse. Yeah, throws. Okay, so I'm trying to conform this to that. Okay, try that. Okay, so parameter expected argument type. Oh, we need a self. Okay. We end up doing the both wrappings because we're trying to make this I messed this up, haven't I? Undo that. Okay. Everywhere I do term, I need to do this. Term. And that. Missing parameter self. Okay. All right. So we've got our rules. We got our build. And so this thing should be a term parser. We wrap it. We call parse to replace this basically, and do everything. So this should it should pass. I can't believe. Yeah. Okay. I don't like writing this level of code just trusting those old tests, I guess. That's the problem. But this thing did its job, and I don't think anybody's referencing this anymore. Okay. So we replaced term with a new style parser. Woohoo. Okay. Now, some refactoring. Okay, let's take this out. Okay, my claim was this is not necessary. Okay, so remove. Okay. And yeah, that's not bad. I don't know. A little space won't hurt. Pairs reduced, left, right, token. All right. That's cool. This one, I don't see any shortcuts through it. Yeah, I'm not convinced this token's first index thing is. maybe that's worth pulling out. Okay, so let's extract a method. Index of token. I think I can write this. Yeah, that's okay. Array token index, yeah. Okay. And I'm going to move that up. Closer to where we calculate the indexes, yeah. Okay. All right, so we move. Okay. I think we are positioned now. Notice that these methods are generic, so they don't know what level of the expression we're being called at. So we'll go back here. You know, you could call them at any of these levels. They are only operating in terms of that combination of stuff that you have, the tuple with the value and the arguments. Okay, all that stuff. It's generic over this stuff. It doesn't depend that it's a term or anything. Same thing here. Make binary. It doesn't care what the operators are. It doesn't care what the thing is. It's really just it's well, it's left associative, but that's the case for basically all basics operators. So no problem there. All right. We're overdue for a break, so let's take like 3 minutes, and I think we should be able to come back and knock out at least half of these. All the ones that look like this have that same structure that we just did. They're going to be super similar, so let's give them a go. All right, so about 3 minutes, and see you then. Hey, welcome back. All right, so my hope is this starts moving forward. I think we get the payoff now from all that setup. All right, so we're going to we got this sub expression, and it should be exactly the same form as this. It's calling, this one calls power with times or divide. This one calls term with plus or minus. So let's just define this thing as sub expr parser equals, all right. Well, we don't need to wrap old because term parser is a new style parser. So that should be okay. And we're going to match dot plus or dot divide. Okay. and we require float types, and we make a binary expression. Okay, so operator by operator basis, basically. And these, okay. All right, so we have sub-expert parser, and this is a new. So I think if we just called that here, if we say return try wrap new self sub expert parser dot parse, it looks like an old style one. It throws, so this stuff goes away. Okay, and should pass. Okay, what do I know? Subtraction. Expression tests. Oh, interesting. Okay. The tests. They actually run the program, so it's like an interpreter test even. Okay, let's see this one. Parse 10. I know this is hard to read. Statements print. Okay. Statement print. Minus. Okay. Is my thing building it backwards? Maybe I gotta test this thing yet. Expression number 1. Wait a minute. Print has expression 1. Op 1, op 1, op 1. Oh, something weird. Sorry, is not equal to, let's make sure this one looks right. Expression op2 of minus of expression op2 minus 1, 2, and then 3. Okay, that is correct. This is printable expression number 1. I'm totally bamboozled. Term parser. We call term. All right, what it looks like it's doing, it looks like it's parsing the 1 as its own thing, and then a minus 2 is its own thing, and a minus 3 is its own thing, instead of treating it as one big expression. I don't know what that means. It means the pluses and minuses. Oh. How about we Get the right value there. That's what I'm talking about. Okay. I guess it couldn't be too easy. Can't help the typos. Okay, so now sub-expression is that. Let's move it up. Relational. Now that one's different. Sub-expression, relational sub-expression, right? Sub-expression, yeah. Okay. Let's see. So I think we'll take this for inspiration. I don't know. We'll get these all in one place eventually, but relational. Oops, I'll just put it up here. Okay. So we got sub-expert parser. Let relational parser equal. Okay, so it should be sub-expert parser, sub-expression. Well, I guess we can just pull it up. Okay, so the relational parser, can't find term parser. I guess we'll need that too, of course. Eventually, all these should be able to sit like top level or almost top level. Okay. Sub-expert parser never used. Okay, so this is a sub-expert parser. Optionally followed by. I don't think I have an operator for that. I have this. And optional. Okay, optional. Well, we need our relational operators. Token type. Relops. Okay. I think we had a match. Any of. This is actually one of. Okay. So we can give it an array of token types. Okay, so relational. Okay, so that's one of relops followed by another sub-expert. Okay, so you have a sub-expert token type. Oh. That's a list. Where's that used? Let's make this an array. takes array of token type. One of rel ops and suffix per parser. Okay. Yeah, so you parse a sub expression. If you want to, optionally, then you can follow it by a relational operator and another sub expression. And then we need to match types and build a binary operator. Which may be different because the types are different. Okay. Match types, left and right. Okay. Require matching types. Okay, and let's go jump to that. Left not equal right. Yeah, it's sort of the same problem. Okay. All right, so we need a matching types method. So it's going to be similar to this. And this is, well, it's getting a different argument type. This is a sequence. So it's a tuple of with an optional, because this is optional. So it's an optional token and expression. Okay, so it's like the other one. Tuple, it's an expression and it's an optional token expression optional. And it returns int string question mark. Okay, and let left token right equal argument, and let token right equal token right. Okay, so split it up. Okay, and then optional, oh, if there is none, then there's no chance of being a problem. Okay. Okay. If token, if left dot type equals right dot type, we're matching, so there's no problem. And otherwise, well, we return an error just like down here. So index of. Pair index of token. And the message, let's find this again. Type mismatch. Okay, that's actually a better message than this one. think that one should be numeric type required, but that's another issue. We're refactoring here. Okay, require matching types. And that's piped in here. And then we need to make let's say make relational expression. Okay, where's make binary? And the reason is the reason for a separate method is it's a different type. Expression and token expression optional. I think we can reuse it. I don't know. If we have to break it apart. Expression. Yeah, that. Okay, so argument let left token right equal argument. If token right is nil, return left. Otherwise, let token right equal token right. And return op2 of token.type left and right. Okay, make relational expression. And now this, it's pretty much like this. Wherever you are. Try wrap new. Well, this time it's a relational parser. And this gets commented for now. Relational parser. Okay, let's build. Run tests. Good. Okay. Let's get rid of that. Now, who's calling sub expression? Expression. Okay, there's the function. Nobody's calling it. Okay, so let's take this out. And we're folding them out. Okay. Now okay, negation, I don't know. Do I want to fight this off? Okay. If not, is token type next token. Try negation, require float types. Turn off one. Okay, this is well, it's a knot. Yeah, basically it's a bunch of knots, right? So let's define it. We'll pull these up. Okay. And again, notice every time I'm pushing, I could release my whole system. So we're meeting, that evolutionary approach here. Okay. Now, the grammar for this then, this is negation. Let's call it bool not parser equals. Okay, well, it's going to be a bunch, 0 or more, knots, followed by prefix operator has to be without a space. That's something I learned. Okay, so match knots, 0 or more of them, followed by relational. Okay. Okay, so we match a bunch of those, and then this produces an array of tokens. The whole thing is a tuple with a relational parser. Okay, so we need to require float types, and we can't assess the type until the end, because we don't know what the type is until we're over here. Okay, but we have require float types. Well, let's require float type and require float type. Okay. Float type. Okay. And let's find that method. Whoops. Type. Oh, we can click through it right there. Okay. Yeah. Okay. We'll take these 2 lines just to remind us. Okay. Require float type. We're doing this. Okay, but our require methods, let's get the headline on that. Well, I'll paste this just for reference. In our case, the argument is a tuple, this and this, and the first argument is an array of token, and the second argument is an expression. Is that right? Okay. And then the result type is optional int string. Okay. Can comment these out. Okay. Yeah, that looks right. Okay, and then I think the tokens to match the types, we just need to verify that. Oh, yeah, we do need to know the tokens. Okay, Let tokens and expr equal argument. If tokens dot is empty, there's no problem because we don't have any knots, so we could just have a string type. That's fine. And then otherwise, we want to, if expr dot type is a number, then we're good. Otherwise, we want to return int. Well, let's do index of tokens dot last. And numeric type is required. Okay. Okay. If there are no tokens, it's a simple expression, return it. If the type is numeric, all is fine. Otherwise, we have knots and a non-numeric type. And we'll mark that last token and go. Okay. Probably wish I had more error info on my expressions, but that's okay. All right. So require float type. All right, that's good. But then we also need to make a unary expression. And I think we'll borrow again. Okay, unary expression, and its type is array of token followed by expression. Okay. And I think, okay, it's just op1. This is the token.type. We're going to be generic over that. If it was negatives, we'd be just as well off. Yeah, so this is token.type. Okay. Make unary. Okay. Let tokens expression equal argument. If tokens dot is empty, return expr. And otherwise, well, otherwise I've got not, but I could have different operators, so I don't want to be too picky. I really want to make sure the innermost one gets attached. Okay, so I'm going to do a reversal. I know that's maybe a little weird. Let reversed equal tokens dot reversed. I guess I'm okay with a view. I'm not going to change them. Okay. And then I'm going to do another reduce. Okay, so reversed dot reduce. Initial result is expr. And then the new result reverse dot reduce result token. Okay. Um, all right. So what am I going to do? Well, I'm going to make an op1 of token dot type and expr so far. Yes. Oh. Well, I did. Yeah. Okay. And I don't know, I'm going to inline that tokens dot reversed dot reduce. Okay. So reverse the tokens, reduce them, start with expression, and append the token types all the way up. All right. So make unary expression. Will not parser make unary expression. Okay. So my claim is just like this one. Wherever it got to. Just like relational, we're just going to wrap new and parse. Wrap new of Boolean not parser and parse, and this stuff goes away and it should pass. All right. Now who's calling this? Nobody. Okay. And let's run that again. I think I've gone too long without checking in. Let's see what diffs we have. Okay, any of... we're handling negation, relational. Oh, isn't this weird? And sub-expression. Relational. Forget what I'm saying now. Sub-expression. Okay. Negation. All right, here's and expr. Let's pull these up again. Okay, so this is and expression. Okay, so it matches negation followed by, sorry, separated by and. Whoops. Bool not parser is negation. Separated by and. Okay. and then require float types and make binary expression. Okay, bool and parser, and then we'll call it with that wrap new style. Okay, sorry if there's some noise there. All right. We got and wrap new boolean and parser parse. All right, should pass. Okay. Now our negation is no longer used. Okay. And we're going to do the same thing. I'm going to copy all this. Okay, so or expression. So this is be the bool or parser. Bool or parser equals bool and parser separated by ors and require float types and make binary. Parser, that's actually kind of a good way to call it too, isn't it? Boolean or. All right. Boolean or. Okay. Bool or parser. Let. Okay, so each time we're taking, what is that, 10, 11 lines, and these 4 lines, kind of judiciously spaced, replace it. Okay. All right. And the expression, well, this is probably the only place that calls this. Try, and the expression, okay, so I think I can do this. Whoops. Wrong keystroke. Let's try this one. I don't think anybody calls this one. Yep. Okay. Good. We're gonna have to check those, but I think we're up at the top. Was that last move good? Yeah, I think we're okay. All right, we got to the top. We got some refactoring to do, I'm sure. And in the end, most of these won't be needed. Okay. But let's see what we can do for the rest. Boy, these exponents. Well, this one, I feel like I want to break this up. I've got this that looks like every one of my binary ones, right? So this is my unary. Let's see, is this working? Value is power. This one's a little tricky, isn't it? So if you do minus x squared, you get minus on the front of x squared. Okay. I'm sorry, I need a quick break. Let's about 3-4 minutes. Okay, excuse me. All right. Minus, okay, so what do? We get the minuses if we find, okay, if we find a minus, we call power again, okay? And if we find another minus, we call power again, and eventually we get to one that doesn't have a minus, and we do it. Okay, so I'm going to split this. Let's rename this to negation. I got rid of negation on the other one, so I think that's okay. Negation. Okay. Now, I think the negations all apply to, eventually you get to one of these, and this is the power. Okay, let's do that. Extract a method, power. Okay, make sure this is all good. Kind of rewriting my grammar a little, but I don't think I'm changing the order of anything. I changed a name. Okay, so now this one is much more like our Boolean. Let's get up here. A negation. Okay. Negation. Okay. And that is, negation parser is, we can repeat minus, and it's followed by we're gonna wrap old self power. Okay. Then right? So we got minus, 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 minus. Eventually we get to a power. Okay. So match all those. And then, well, let's take it from up here for consistency. Require float type, make unary. Require float type, make unary with the token type. Okay. And then to do this, we're going to call wrap new, return try wrap new of negation self and negation parser dot parse. Okay. Cannot convert value of token expressions to expected argument type. I think maybe wrap old is making it unhappy. Int string, aka array of token, array of expression, array of tokens. Sorry, what's the difference? Okay, let's get this up here. Okay, term parser, negation parser. I want to compare Boolean not, star, match not, and, oops, and wrap alt self require float. Okay. Wrap new self negation parser. Well, I don't need to wrap it if I've got it here. Negation parser. I still wrap a power. Okay, do I have any syntax? Well, nobody should be calling this now. Okay. Okay, where are you? Negation. Okay, negation parser wraps power. Well, I think power. Let's go down there. Power calls factor and it checks for exponent and it requires float types and it does that. Okay. So let's let power parser. Wrap old self factor separated by match dot exponent. Power parser never used. Okay, let's use it. Power parser sounds important. Okay. Should pass. Okay. All right, and then where power is, oh, right there. Nobody's calling that anymore. Okay, and we've done power negation. Okay, we did power negation. Handle negation, Urimus, and power. Okay, we're down to something painful. Okay, because it's just large. This has got all the cases. Okay. Well, a factor. Sorry, parenthesized expression. I want to do the ors. Maybe I should go inside and do these first. Okay, so this one we want to match. We want to match left parent. And then we don't need the, normally we'd write this, but we don't need the parenthesis anymore. So we'll do this expression wrap old expression. And then this time we want to keep the expression and we don't want to bother keeping the right parent. Okay, now expression delivers us, and it's an old style, it's still an old style parser, but it delivers us an expression. So the type of this is expression. There's no checking. The only trick is this. Okay, the message is different. And I don't mind messages being different, but I think we can do better than we're doing. Okay, so I think if I call this parenthesized parser dot parse, sorry, I gotta do a wrap new. Try wrap new parenthesized parser dot parse and return that. Missing argument. Yeah, self. Always leave that off. Okay. Missing parent. Did not find expected value is not equal to missing parent. Okay. We have a way to do that. Now, really, it's on the match. Okay. Match. It really only just, it calls satisfy, but if we look at satisfy, it has an optional argument. It takes a message as an optional, and that's where this did not find expected value comes from. But I would really like to say missing and then the token thing. So what I want to do, I'm going to define a map. Token names is, I don't know if it'll infer it for me, but I want to say that right parend goes to right parend. Okay. And I want to say cannot be resolved without a contextual type. Okay. This is token to string. Okay. That should be better. Oh, of type token to string equals. Okay. Token has no member right parent. Token type. And I don't know. I wish this were deferred. Let's let the message equal token names sub token type. Otherwise, missing, let's say, expected character. Is that just this? Okay, so if I have the character, I want to return it. If I don't, I'm not. And then I'm going to pass that to the message. myself up here. I want missing. Maybe I'll put the quote up there. Revenue failure. Oh, this is probably an improvement. Okay. What did he get? Missing expected character did not find expected value. Yeah, I think that's an example of one I'm willing to accept a difference on. I don't require exactly the same messages, but I want everything to have a message that has a message now. That's a fine message for that. Okay. Well, where are we here then? Find parenthesized. Okay. So we've got that going. Okay. Make sure we're all green. Let's check in. Call it a wrap. Handle parenthesized expressions. Change error message handling for match. Okay. And yeah, that's mostly what we've been doing today. And we'll just do remaining expressions. Okay. We'll pick up there tomorrow. I think we're getting to the bottom of things. There's still I mean, these all have a bit of stuff to them, but I think we're mostly there. There's some complexity. It'll take a while, but I hope we can finish the expressions tomorrow. And once that's done, we'll move on to statements. Maybe there's printable. What was the other? Oh, dim info and printable. Maybe we'll probably try and get those in place too. So, and move on. I'm hoping to finish by Friday. That's probably a little too ambitious because yeah, I think it'll take most of tomorrow to finish the expressions, and I don't think we can finish the statements in one day. But we're close to the end. I think we're getting there. We got the pattern of it now, so that should move forward pretty well. And we'll have some cleanup because we got extra versions of these functions. But and I think some of them can move over to expression probably. They seem to be built on expressions and tokens and producing expressions. So yeah, that's reasonable. So a bit of refactoring to do, but we're making progress. So thanks for joining today, and I hope I catch you in the future. Have a good evening and take care. Bye-bye.